Okay, welcome to Fremont Unified School District Lesson on Light for first graders. My name is Dr. Joyce Bluford. Most kids call me Dr. Joyce, and we're going to learn all about light today. I represent the Math Science Nucleus, where we manage the Children's Natural History Museum. You can find a lot more information about us online, and at the end, there will be our website. But right now, I want you to look at this picture here. What is light? If you notice, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. And if you notice, as I asked some of you to look at where light is, and notice it's number 5. That's visible where the rainbow is. The rainbow colors, when you put them all together, it gives you white light. But their sisters and brothers are also other kinds of waves. We call them electromagnetic waves. Now also, we will ask questions at the end. Hopefully we'll have about 10 to 5 minutes at the end where we will ask questions. But remember, there's going to be 500 first graders on this class. Now, if you look at number 1 and 2, 2 is radio. I know you guys are all familiar with radio. So radio is related somehow to visible light. And then you have microwave, infrared, and then that's on one side of light. Visible light includes all white light. Number 6 is ultraviolet, X-rays, gamma rays, and cosmic rays. These guys are all related. So let's take a look at what we're going to learn today. We're going to learn about light. We're going to learn out what is light, how does light move, and how do we see objects in the dark. And then at the end, we're going to do some experiments with shadows. And these will be things that you can do on your own, or you can do with a friend. Shadows are kind of fun. Light is really mysterious. This is a little book called Light Magic. And so this is going to go over parts of what we're going to learn today. Now, if some of you are coming in late, this is on our website and you can read it yourself or have your parents read it to you. So, Light Magic.
Light Magic by Joyce Bluford. Animated by Doris Rea and Hagos Tewaldi. Read by Phoebe Chen. It was getting dark in the house. I reached over to turn on the light. I wanted to read a book. The bulb got bright for a second and then made an explosive sound. It went dark. I was too lazy to get another light bulb. Without light, my eyes got heavy and they wanted to close. I thought I would go to sleep, but in the distance I noticed a caveman. Was it a dream? The caveman only had fire to produce light when it was dark. He only had the stars up above to guide him at night. The sun to early humans was very important because it brought light so they could see. They did not have television or radio, but they did make stories with shadows. This dog would come out at night and... The dog got larger and larger when the caveman got closer to the fire. The dog got so large, it ate the caveman. I woke up thinking the shadow dog ate the caveman. What a way to go. I drifted back to sleep, but then my door opened and in came an Egyptian who was looking for light. The light bulb in the hall was burning bright, but I noticed she had her eyes closed. "Open your eyes, silly," I exclaimed. "Oh, thank you. I forgot that eyes help you see light. I am a very old woman." She then started to tell me a story about fire and light. One day, when the fire was very, very hot, the sand turned into a hot, glowing glob. They took the glob and let it cool down. It was a substance that you now call glass. They played with it and noticed that it did something magical to sunlight. It produced different colors, like an object we sometimes see in the sky after a storm. The glass created a rainbow. The glass was magical, making colors from white light. The old woman continued. She left and I started to dream about rainbows. The rainbow turned into a man. My teacher always refers to it as Roy G. Biv. R is for red, O is for orange, Y is for yellow, G is for green, B is for blue, I is for indigo, and V is for violet. Every time I look at a rainbow, I always see Roy G. Biv. I mainly see Roy when the rain is just stopping. I woke up again and asked myself, so what is a rainbow? Is it a road for people in the sky to come to Earth? Is it an angel who took up painting? Or is there a scientific reason? I wonder if I could experiment and find out what is going on. I couldn't make a large rainbow by myself. However, I did have a prism that made a rainbow when I shined a light through it. The prism refracts light and breaks it into many colors of the rainbow. Violet rays have more wiggles as it moves. Red rays have less wiggles. All light travels at the same speed, 186,000 miles per second, or 300,000 kilometers per second. That is very fast. So blue has to wave extra to keep up with red. This separates white light into rainbow colors. I guess if I look in the mirror, I should look like a rainbow, but I don't. I am only being reflected so all the white light moves together. Different types of mirrors can make us look silly. Light is reflected when mirrors are curved, so the light bounces outward or inward. A lake can reflect an image. Any shiny surface can also reflect an image. Light moves all over. It can refract and reflect. It also can diffract, which means it goes through a small opening and spreads out. Light is a magical experience, from when the sun rises to when the sun sets. The creation of light inside our homes allows us to see all the time. It is a wonderful world when we have light. We can walk outside late at night, and we don't even have to carry a torch like our caveman friend. The end.
So this was just a story about light in general, but just imagine a life without light. At night, we'd have to sleep when the sun goes down. So when man invented how to make light, the light bulb and even fire, it really helped us a lot to stay up late. Now, in the little book, we talked about reflection, refraction, and diffraction. So everybody, let's say the word reflection. Reflection. That means that light actually bounces, because light is not nothing, it is something. It's something we call photons. And so, but it only bounces off shiny surfaces, including water, metal, or mirror. And so that's how we see ourselves in the morning. And if you think about it, when we finish these lessons, think about all the reflections that you see. Now, what in the world? How do we know that it's being reflected? Let's look at how humans actually discover how light works. Now let's look at picture number 1. The little boy is kissing himself. Oh, then he realizes, oh, I have a friend. Oh my goodness. He bounces right off, just like the light photons bounce. But he will learn that light bounces off, and that's not a real image. Now let's look at number 2. the little baby there thinks he's fighting. He thinks he's seeing something, and he goes, oh, I don't like you. So he starts fighting. Boop. Oh, he just learned about reflection. Now in number 3, and you sometimes see this in stores all the time, you'll see little kids look in a mirror and then look in the back. And what is she looking at? She's trying to find the little girl that looks like her on the other side. Will she find it? No. That's because she doesn't understand that this is called reflection. Now, let's take a look at reflections at different angles.
Let's look at the reflection of a dinosaur at 90-degree angle. Is it the same on each reflection? Is it what we call a mirror image? So let's take a little detail of one side and the other side.
So if you notice there, when they're at an angle, you see different positions. And this is also how, when you're looking in a mirror at different angles, you can see different views. That's sometimes how we can see oncoming cars. Next time you go in a car, think about what would your parents do without a mirror looking in the back. Okay, now look at this little boy. Where is he coming from? Boop, boop. He's coming in from the side. That's just his image. He sees it and he's thinking, oh, I can go that way, not realizing that's him he just bounced into. So even when you're older, you sometimes can make a mistake. But that's what fun houses usually are when you have mirrors. Magicians know how to use mirrors very good, because in this picture, it really looks like he's coming from the other side, but he's not. Now, even animals. Now look at this, look at number 1. That little doggy there. What is he thinking in his head? He's thinking that, oh my God, there's somebody there and I want to play with him. But it's only a reflection. So he sometimes can do this for up to 10, 15 minutes before he realizes that's not another dog. And then on number 2, same thing, but it scares him. He's walking along and then all of a sudden he sees, oh my goodness, another dog. And he kind of jumps. Now, this is very common. And when you go out and you're near a lake, you will see a reflection on the water surface. But if you notice, like look at number 1, that is snow. And because the lake is moving, the image looks like it's moving, but the bottom part is the image. And if you look on 2, that's the same thing. Sometimes when the water is so calm, you don't know which side is going on there. Okay, so that was some examples of reflection. Now, let's take a look at refraction. Now, with refraction, that's something different. That means that it's going through another object. And we're going to see some, when you're making shadows, you'll need some light that actually kind of goes in. So we're going to be looking at this refraction. So let's say that word, refraction. Refraction. And that's when it goes, oh, and I got the wrong explanation there. This is when the photons go through a subject. That's the same one I have, so just excuse that definition there. Refraction goes through an object. Now, this is an example. Now, is this magic? Or is it refraction? Now, let's take a look at it. That straw looks like it's bent. So let's go and let's see.
Refraction can make us see things that isn't really happening. This straw looks like it is bent. It's in the interface between water and atmosphere. 2 different mediums that causes light to refract. So let's take a look up on the top And we'll notice that we have another perspective. So when you look up on the top, it looks like a regular straw.
Okay, now it looks straight. Now children, there is a lot of you and I can't answer your questions right now. So save your questions and raise your hand at the end, please. Thank you. So let's continue with refraction. Now, look at picture number 1. The mom took a picture and used refraction to make the lower body of her child look huge. But is that true? No, it's an optical illusion. Now look at 2. If you have glasses, you got to remember glasses uses the principle of refraction to change light so you can see better. But as they're using the glasses back and forth, you can make things look very weird. Now, where do we have refraction? Well, you guys probably have heard about telescopes and microscopes and binoculars. And these are they use the principle of refraction with lenses to see how light can go through and then change. You can make it bigger, you can make it smaller, you can make it more detailed. This is the science of optics. So there's actually people, scientists, which are physicists, who actually study the science of optics. And that's so we can all see better. At one time, we didn't know all we know now about how light goes through things. It is complicated, but they create things that we use every day. Now, let's take, in the book, it talked about Roy G. Biv. Now, let's go. Roy, R is for red. O is for orange. Y is for yellow. G is for green. B is for blue. I is for indigo. And V is for violet. Now, let's look at what this refraction does. Refraction can actually, when it goes through a substance like a prism, notice it bends on one surface, and then as it comes out, it bends on another. And that's what gives us a pure rainbow of Roy G. Biv. Now remember, not all rainbows. Sometimes you see multiple rainbows, and that's caused by a little bit of a different process. But Roy G. Biv, if you notice the moving wavelengths there, in the book it talked about them waving at you. And so red waves slow and violet waves fast. Okay, now if you notice, there is something right next to me right here. Can you guys see that? Right here, we're gonna kind of, you probably can't see it, or you should see little flicks of light. Now if I take this off here, oh no, I can't take it off. This is nothing that what we call a fiber optics, okay? So let's take a look at how that works. Now, is that reflection or is it refraction or is it diffraction? We haven't done diffraction yet, so it's probably just reflection or refraction. Let's see, make a guess, and let's figure out what's going on here.
Fiber optics is a way in which you can move light. Notice light goes the span of the fibers and comes out on the tips. What causes that?
So these little bits of light coming out, what can be doing that? Well, this is, as I said, is a plastic with a little bit of an element called boron in it. Boron is actually an element. And boron allows light to go straight, but not out like that. And so what's happening here is light is being formed at the beginning here, and then the light is going through these strands here and comes out. But plastic is one substance, and the out here is air. And so it's going through another substance. You got to remember, air is a substance. And so as it's coming through, it makes a little bend. It's not bending twice, or otherwise that would make a rainbow. So this is just making a flick of light. So what you see is light coming at the ends. So that's pretty cool, huh? Now, also, the invention of fiber optics is what allows us to have our telecommunications now, because light is something that can create energy and work. And so these fibers help us with communications today. When we make a phone call, we could do it real fast because light, if you remember in the book, 186,000 miles per second. That's fast. Okay, now let's take a look at, let's turn this off so we don't, okay, 1 minute. Okay, so now let's take a look at diffraction. Now, many of you might not have ever heard of this term, but sometimes, like when you have funny glasses or you see things double, that's when we call that diffraction. If you notice on the first picture there, the light goes through something very, very small. And then when it comes out, it goes into little packets. Now, this is actually pretty cool. It took scientists a long time to figure out how we can use this in diffraction. But now what it does is it duplicates things in little packets, and it does something kind of weird. So if you look at number 1, the light is coming straight in. Then it goes through the little hole there, and then it's curving as it's going out, and it's doing it in waves. And if you notice, it looks kind of like rainbow colors, and that's going to be important. Now, also other things diffract too, just so you realize that this word, like waves diffract, anything that goes through a small little hole will come out like these little packets. Okay, now, I know we don't use CDs that much, but CDs uses principles of diffraction. So if you ever turn it around where the data is being stored, that shimmering is diffraction. Even when you go outside, think about it, when the sun comes up, it usually peaks. And if there's clouds in the way, the light will go through some of the clouds, but some of it can't go through. So it's squeezing through, and it makes it look really pretty. And that is caused by diffraction going through a small little hole. Now, also, look at these little bubbles here. Let's take a look at that bubble on the left. And you'll notice that it repeats things. And you can even see there's 2 things going on here. It's actually reflecting, if you can see, there's like a building, and it's reflecting on the other side. And so this is actually causing this diffraction of multiple rainbows. So like in the picture on the right where you just see the bubbles, you'll see the pattern of Roy G. Biv, but it's mixed up quite a lot. And that's because this is diffraction. Okay, now I'm going to play this little video here, and I want you to think about what's going on. And I'm going to repeat it because not everybody will see it all at the same time. This is what we call a hologram.
This is a hologram created by laser light. Notice this is a Japanese young lady who puts her hand out and it's raining, so she takes out her umbrella so she doesn't get wet, and then when it stops she puts the umbrella away. Now notice when I move the camera around, you start seeing it move in different directions. This is all a projection of light, and light can be distorted by many, many things.
Now, this is where that hologram was looking, if you guys can see that. And you go like, where's the little girl in there? Well, this uses a series of lenses. Let me take this one out here. If you notice right here, you have a funny lens. So when I can see weird things when I look through this, but light comes from underneath, it goes in here, and let's take a look at it again so you can see this cylinder. And this was all created by a laser, and how it's projecting the image in the center is through diffraction. Oop, let's go back.
This is a hologram created by laser light. Notice this is a Japanese young lady who puts her hand out and it's raining, so she takes out her umbrella so she doesn't get wet, and then when it stops she puts the umbrella away. Now notice when I move the camera around, you start seeing it move in different directions. This is all a projection of light, and light can be distorted by many, many things.
Now, the unique thing about these holograms is it's not a movie. It's a movie basically of light being projected. So it's different than just like a movie. But you got to remember also with movies, imagine movies being produced without light. The first cameras were basically just a little slit, and then they would have special paper that would record that image. So even cameras and movie cameras have to use light in order to produce these images. And heaven knows what, when you guys become little scientists, what you guys might invent. Now, light cannot go through many materials. Let's take a look at this. Can it go through a window? Yes. Through a ball? No. So we have these different words that we use. When you can't see anything through, it's called, and this is, the words are written on number 2, opaque. It can't go through. And this is going to be important when we start looking and making shadows. Then if some of the light can go in, that's called translucent. Now if it's glass, that's called transparent. So let's say those words. What happens when you can't see it at all, like the basketball? That's called opaque. Let's say that word, opaque. Now let's look at the other one, translucent. Translucent means that some of it will go through, but not all of it. That's called translucent. Good. Okay, let's say the last word, transparent. Transparent. That means that all of the light can go through. Now, is this important for making shadows? Maybe so. But let's first understand what is a shadow. Because we're going to, now if you ever noticed it, if you looked in the sky, now parents, you can take your children outside after this lecture and go outside and see where light comes up. Light, which is our sun, comes in the east, so it'd be toward Mission Peak, and then it goes all up, down, and goes into the west. Now, does it make shadows? Look at this picture here. Sun, and look at the numbers on there. That's 11 o'clock, 1 p.m., 7 a.m. See that where it's going? Does the light and change and cause different shadows? Yes, but also look, does the shadows change length? So we have an experiment that we do at Matos Elementary where the kids go out and record the shadows just so they understand. Because like during the summertime, the shadows, the sun is higher up in the sky and the shadows are littler. When it's the winter, when the angle is different, they're longer. It's kind of neat to see about the shadows. Just like, remember the little girl that was afraid of her shadow? Well, this way you can understand that shadows can help us do what? Tell time. So before there was anything like a watch, there was shadows. And early peoples realized that shadows could tell time. Now, this is a sundial that we have in front of our museum here. Now, if you look at it, what time is it? If you look, the numbers there are 6, 4, 2, 12, that's noon, 10, 8, and 6 a.m. Now, the shadow, but you got to remember too, shadows only work when there's light. It doesn't work when it's dark. So what time is it? It is almost 2 o'clock when I took this picture. So if you ever want to come by the Math Science Nucleus and see this big yellow thing, it's a sundial. And so that's when you can tell time by shadows. And for most human history, shadows told time. Now, oh, look at the little girl that's scared. Look at number, the first one there. That's the one I was talking about. So the little girl with the pink coat, she sees a person. She doesn't know what it is. She's only about one and a half years old. She's looking at it and she's running away, but it runs toward her. What is she gonna do? She's gonna fall. She doesn't know what it is. Then later on, so like the picture on the right is a little baby that doesn't know what it is and trying to grab it. Oh, and she's trying to grab it, and can she grab it? No, and she falls down. So there's all these little things that happens when you see the shadow and you don't understand. Now humans, you have to remember, as we learn, we understand, oh, that's just a shadow. But the little girl, you can't, she was crying and screaming, and she really thought the boogeyman was gonna get her. Okay, now, do cats do it? Oh yeah, cats' brains aren't totally developed either. Mainly little kittens will do that. You can play with laser light, but once they get older, they go, oh, I'm not gonna try to get that, that's stupid. But young cats don't know what that is, and it's gonna take them a while to figure it out, that there's nothing to grab, okay? Can you fool them? So if you have a dog or a cat at home, even with squirrels and guinea pigs, that also works. Okay, dogs and their shadows. Does it happen to dogs? Yep. Number one is pretty common. A lot of these big dogs, because they have big shadows. Look at that German Shepherd. Yes, again, they're young dogs because it's going through their brain. What is this? I mean, if you think about it, a shadow is kind of odd. It's there, you can see it, it's moving with you. And then look at number 2 there. The little dog is seeing it on the side and they think it's another dog. So it's barking at it like, I'm gonna get you, stay out of my backyard. Not realizing it is himself, and it is just a shadow. And you got to remember, shadows will go away when the sun moves. So it's important recognition. Okay, now we even have a whole holiday in the United States called Groundhog Day. And this is mainly back east because here in California, we don't have groundhogs. But this is a little groundhog there. And they have a saying that if the groundhog comes out and sees his shadow, that means it's going to be spring early. If he doesn't see the shadow, that means it's going to be late, that you'll have 8 more weeks of winter. Now that doesn't make too much sense, does it? Now you gotta remember, a groundhog is just a big, kind of like a beaver, looking like a beaver. And when it hibernates, so that means when it is cold, it digs a hole and then goes inside and then hibernates. And what it does is it starts peeking through to see if he should come out. And why does, if he sees his shadow, that means that there's no lot of clouds in the sky, and so he'd see the shadow because it's bright out. So that's where this whole myth came out, that if he sees a shadow, that means it will be spring sooner, spring-like weather. So we call that Groundhog Day. Do you know when Groundhog Day is? Let's see, do I know when Groundhog Day? It's in February sometime, so just before spring. So I think it's February 2nd, and they make a big deal about it back east. And they even have, it's called Pete the Groundhog. He has a special place that they have for him. I think it's in Pennsylvania somewhere, where they actually make a big deal, have a Groundhog Day parade, and it's just kind of fun. So this is the ultimate use of shadows. Okay, now how do you make a shadow? Well, let's look at number 1 and number 2. Number 1, is that for real? Oh, wait a minute. How is there another shadow pushing him in the side? Look at that. There's another person coming in where he is, making it look like he's weird. Now, if you look at that, doesn't that look like a ghost? In most ghosts, it's little at the bottom and then goes out big. So a lot of times, the myth of ghost actually comes from shadows. And so you can kind of play with them. Now look at this shadow there, the little animated gift there has a shadow, just like I had in the book. I had the caveman and the dog, but that shadow doesn't make sense because in there's the dog, the dog turns on and bites him, and then the hand tells him, no, that was not good. Can that actually happen? No. So if you look at the picture in the upper left-hand corner, you'll see that there's a light and then the object and then the shadow. If you get in the way, it won't make the shadow. Okay, just like in picture number 1, the other person is hiding in the other side. But you can make some real kind of cool movies. You got to remember, before there was a lot of television, what did people entertain? Shadows. Okay, let's take a look at these. Okay, so you can make some of these shadows at home. On our website, we do have a lot of different pictures that can help you make your own shadow. But some of these you can use one hand, some of them you can use 2 hands together. Now, if you notice on picture number 1, you're using 2 hands. Now you notice that it all has to be in correct position. In this, what is number 1 trying to be? A goat, if you notice. And so you can play games with your little sister or brother or even your older ones and try to figure out what animal you're making. Now on number 2, is that 1 hand or 2? It looks like 1 hand, but it's actually 2, and it's going up like this. You got to learn how to use your hands. So and then if you notice, there's a little eye, so you have to make a little, so just enough light goes through. So it takes practice to make really good shadows, but it's kind of fun to understand how you can make images and make people think they're seeing something when they're not. And remember, I use the term optical illusion. So you're trying to make them think that's a real bunny or that's a real goat. Okay, now let's look at number 1. If you notice here, the hands are clamped like this. So you think it might be 1 hand, but it's not. But notice how you have to make your hands go up and down to make that movement. Now, if you look at number 2, you'll notice that this young man is able to make almost like a puppet. So you can actually kind of play with 2 people, can make shadow puppets and make a whole story of different characters. So it takes a little bit to figure out how to move light to kind of have fun. And at the end of this, we will have our website, and you can look on there and get the worksheet. And there's, I think, about 8 different positions you can put your hand on and make your own shadows. But you can also Google online making shadows, and they have so many shadows because a lot of people like to have fun just doing it cheap. No money, just light. Okay, now make sure though, because this is a common problem that we have, that you don't get in the way. So that means the light on here, you have to be away from the light source, because if you get in front of it, it'll make your body be the shadow, and a lot of times it would be too much. Now I've been trying to figure out, that's a dog. I don't know what the second one is. Take a look at the second one. Is that a jellyfish maybe? Or, oh no, I see it. It's an antelope. So the hands are the going up, that's the horns. Okay, I see it now. Okay, now let's take a look at some of these long-term experiments that we can do. Now I'm going to show a video, and then I'm going to try to explain this more, because this is kind of fun to do. It's a way in which you can capture the sun, but it's kind of a little difficult. So let me play the video first.
We are now collecting shadow data. We have a nail that's having a shadow, and we're recording it. Record it during parts of the day and see if the shadows change. Remember, north has to be in the direction of north, and the data set will be valid.
Okay, so on this one here, we have shadow on number 1. And so this is how you would make it. So this would be your collection right here. This is just a you just cut a half a sheet and then staple it. So you would put your data in here because you want to collect it maybe every week. And so you would need a, let's see, can we all see this? As you go down like this, you have to put a nail. So you have to get some kind of, so this is what your parents would do. Like this is a Play-Doh. You use a nail, and then you kind of cut a square on there. So basically what I did was I folded this like this, and I cut a little notch. And this is where you're collecting your data. So then you put this on top of that like this, okay? You have to go in the same place and then look at the time. So you have to find a place in your backyard or maybe in the front of your house. And then what you go, and then you look at it. So if you look over here, you could see where the shadow, the light would hit it, and then this would record. So now if you notice, this was 1 day. So each one is a day. And then if you notice that the shadow, can you guys see this? Changes every day here. So we have that, or every hour. So on here, and you would have to figure out, is it the shadow the longest at noon, or is it the shortest? And so this is how you collect your data. So you might go on, you know, maybe do an experiment for 4 weeks, go out on Wednesday, and then you would put your data in there, and then you would take them all out and compare. And you can see that there might be a change as you go from 1 month to another month. It's kind of neat. Now, daylight savings, or we're going to have to change the clock pretty soon. So you got to remember, you got to take that into account. You should do it when the time doesn't change. So this is how we learn about how shadows are real important. Okay, so that one I probably might have some questions on. But I think what I want to do now is I want to go back to the story. I want to go back to, let's see if we can go back here. And I want to read that again, because when you first heard it, you might not have gotten all the information, because in that one storybook, there is a lot of information. So let's just go back what we've learned so far. Refraction, reflection. Remember all these funny little scenes? Okay, reflection. So we're going to listen to this story one more time, and I want you to remember what we've just learned so you really can understand that light is not magic if you understand it. Then there is a way to explain it. So,
Light Magic by Joyce Bluford, animated by Doris Rea and Hagos Tewaldi, read by Phoebe Chen. It was getting dark in the house. I reached over to turn on the light. I wanted to read a book. The bulb got bright for a second and then made an explosive sound. It went dark. I was too lazy to get another light bulb. Without light, my eyes got heavy and they wanted to close. I thought I would go to sleep, but in the distance, I noticed a caveman. Was it a dream? The caveman only had fire to produce light when it was dark. He only had the stars up above to guide him at night. The sun to early humans was very important because it brought light so they could see. They did not have television or radio, but they did make stories with shadows. This dog would come out at night and... The dog got larger and larger when the caveman got closer to the fire. The dog got so large, it ate the caveman. I woke up thinking the shadow dog ate the caveman. What a way to go. I drifted back to sleep, but then my door opened and in came an Egyptian who was looking for light. The light bulb in the hall was burning bright, but I noticed she had her eyes closed. "Open your eyes, silly," I exclaimed. "Oh, thank you. I forgot that eyes help you see light. I am a very old woman." She then started to tell me a story about fire and light. One day, when the fire was very, very hot, the sand turned into a hot, glowing glob. They took the glob and let it cool down. It was a substance that you now call glass. They played with it and noticed that it did something magical to sunlight. It produced different colors, like an object we sometimes see in the sky after a storm. The glass created a rainbow. The glass was magical, making colors from white light. The old woman continued. She left and I started to dream about rainbows. The rainbow turned into a man. My teacher always refers to it as Roy G. Biv. R is for red, O is for orange, Y is for yellow, G is for green, B is for blue, I is for indigo, and V is for violet. Every time I look at a rainbow, I always see Roy G. Biv. I mainly see Roy when the rain is just stopping. I woke up again and asked myself, so what is a rainbow? Is it a road for people in the sky to come to Earth? Is it an angel who took up painting? Or is there a scientific reason? I wonder if I could experiment and find out what is going on. I couldn't make a large rainbow by myself. However, I did have a prism that made a rainbow when I shined a light through it. The prism refracts light and breaks it into many colors of the rainbow. Violet rays have more wiggles as it moves. Red rays have less wiggles. All light travels at the same speed, 186,000 miles per second, or 300,000 kilometers per second. That is very fast. So blue has to wave extra to keep up with red. This separates white light into rainbow colors. I guess if I look in the mirror, I should look like a rainbow, but I don't. I am only being reflected so all the white light moves together. Different types of mirrors can make us look silly. Light is reflected when mirrors are curved, so the light bounces outward or inward. A lake can reflect an image. Any shiny surface can also reflect an image. Light moves all over. It can refract and reflect. It also can diffract, which means it goes through a small opening and spreads out. Light is a magical experience, from when the sun rises to when the sun sets. The creation of light inside our homes allows us to see all the time. It is a wonderful world when we have light. We can walk outside late at night, and we don't even have to carry a torch like our caveman friend. The end.
Okay.